champions, welcome back to the Brahmastra 2.0 series, and in today's video we are going to discuss the most important questions from the chapter Amines. Okay, so if you watch this one video and practice all these questions, then there's a huge probability that you will get full marks in this chapter. So first, before discussing the questions, let us start with understanding the mark distribution or weightage of this chapter. So this chapter carries only 7 marks, and this 7 marks is distributed like 5 marks. One question will be your long answer, and there will be two 1 marker question. 5 plus 2, 7 marks is done here. Okay. Now let's go and see the first question. So you will be here I'll be giving you all the MCQs. First, all the MCQs here are of HOTS level, that is high order thinking questions. Okay, so let us start the first question. Decreasing order of basic nature in aqueous solution is. So here you should remember the basicity order is 2 degree, 1 degree, 3 degree. Okay, if the R group is methyl. Okay, and if it is 2 degree, 3 degree and 1 degree if the R group is ethyl. Clear? Now let's see the first one here. If there is any other so what are the compounds that is given to us? The first compound that is given to us is NH3. Okay, next we have is C6H5NH2. Okay, next we have is CH3NH2. Okay, and then we have is CH3 whole 2 NH. Clear? This is there. Now what I can do, you can see that these two groups are there which will be more basic. This one will be the least basic. Why? Because here we have in this aniline, right? This is aniline. Structure of aniline, if you see, this is like this. So what you can see that the lone pair of nitrogen is involved in resonance. It is not available for donation. If it is not available for donation, its basicity will decrease, right? So the least one will be C6H5NH2, and I have 2 options for that. I can eliminate this one. Now after that there will be NH3. So here also NH3, here also NH3. Okay, and after that you will have 2 degree and then you will have 1 degree. Okay, no, sorry, 1 second. Here I have done a mistake. Now see, this is in aqueous solution, right? Always remember, in aqueous solution 2 degree will have more. Yeah, so correct. So this one will be having 2 degree, then 1 degree. So that is why option number C is my correct answer. Okay, moving to the next question number 2. Identify the product in the following reaction scheme. So first of all, C6N5NH2 is there. Okay, so let me just draw that. You have aniline in the first go. Okay, after that what is there? You are treating it with AC2O, means acetic anhydride, that is CH3COOCOCH3. Now what will this do? This N will react with this one will come and this one will go out. So there is acylation here and I will get a compound like this, which is NHCOCH3. Now with this what will happen? Br2CCl4 if you are treating. So with bromine what will happen? With bromine there will be a para substitution will take place because this is a donating group. Okay, so what I will get here? You will get here the compound that is NHCOCH3 and then we have bromine here. Okay, now this bromine with the hydrolysis, this one will go out and you will get here a compound that is H2O. So we have NH2 here and I have bromine here. Clear? This is there. So this compound will be para-bromoaniline, which is option number A here. Okay. Next, moving to question number 3. In the chemical reaction, the compound A and B respectively are. So if you have Na, NO2 and HCl, this NH2 gets converted to what it will form? This will form your N2 plus and Cl minus. Okay, it will form NaNO2 and HCl, that is N2 plus and Cl minus. And after that, when you treat it with HbF4, it will give me fluorobenzene. Okay, it will give me fluorobenzene. So the first one, that is A, is benzene disonium chloride, and D, then it is fluorobenzene. So option number D is the correct answer. Let us see the next question. N2 gas is liberated when this HCl and NaNO2 reacts with the following compounds. Now see, with primary amines, okay, you will get alcohols on treatment with nitrous acid and N2 gas. So 1 will react, and you can say this is also primary amine, 4 will also react. So 1 and 4 are there in which option? Here 1 is not there. Okay, here in all other options we have 1 and 4. Now let's talk about urea. Urea will also release ammonia gas when you treat it with this one. So urea will also react, but yes, amide will not give, so 3 will not be there. So I can eliminate this to option D is the correct answer here. Okay. Next question, identify C in the given sequence of reaction. Okay, so first of all, CuCN, KCN is there with benzene disonium chloride. So that will add the CN group here. So A will be benzene ring, okay, with the CN group. Okay, then lithium aluminium hydride is a reducing agent. So that will reduce this one to give me CH2NH2. Okay, now after that, with nitrous acid, this one will be further oxidized, and we will get a compound CH2OH. Okay, so that is C. So what will be this product? It is benzyl alcohol, that is option number C. Next, nitration of aniline in strong acidic medium also gives meta-nitroaniline. Now see, if you see the structure of aniline, okay, this is a electron donating group, right? If electron donating group, then must be ortho-para directing. But what we observe is, in this aniline, if I do nitration, okay, concentrated HNO3 and concentrated H2SO4, we get enough amount of meta product also. So why does that happen? Now see, NH2 has lone pair of electrons, right? So it can behave as a Lewis base. And here you have ample amount of H plus because strong acids are used. So with this, what happens? This aniline gets converted to something called as NH3 plus, which is my anilium ion. Okay, now this one is a plus charge now. Now once this is plus charge, it will attract electrons. It will pull electron towards itself, right? If it pulls electron towards itself, then the compound will be a electron withdrawing group, and now it's of a electron withdrawing group, it will give meta position. Okay, it will, the groups will be attached at the meta position. Clear? So we will have here in electrophilic substitution reactions, amino group is meta directing. Okay, in spite of the substituents, nitro group always goes only to the meta position. No. In acidic media, the aniline is present is anilium ion, which is meta directing. So option number D here. Next, the correct order of the basic strength of methyl substituted amines in aqueous solution is. So for methyl substituted, it is 2 degree, 1 degree and 3 degree. Okay, so I have first of all 2 degree, here it is 3, here it is 3, I can eliminate 2 degree, 1 degree, 3 degree, that is option number B here. Next, the reagent R in the given sequence of chemical reaction is. So first of all, bromine you have taken, and then Na, Na2 and HCl, that will convert this one, and after that R is there, means this N2 group is completely removed. So for that you can use, actually if you want to just add H group here, so you can add ethyl alcohol, okay, that will give you OH plus, which will come here. So option number B here. Next, the product formed in the following sequence of reactions. So first of all, CN is there with lithium aluminium hydride. So after adding lithium aluminium hydride, you will have CH2NH2. Okay. Then after NaNO2 and HCl, means you are treating it with nitrous acid. So that will give me CH2OH. Okay. Then when you so first of all, this is there, NaNO2 and HCl will first convert it into a benzene disonium chloride. You'll get a intermediate stage, and then with water you will get benzyl alcohol. That is option number B here. Next, coupling of benzene diazonium chloride with phenol occurs in dash medium and with aniline occurs in dash medium. Okay, so see, coupling of benzene diazonium chloride with phenol. Okay, so you have coupling of benzene diazonium chloride, okay, with phenol. Now if you see, phenol is slightly acidic in nature, so the reaction will take place in basic medium, and this aniline is slightly basic in nature, so reaction will happen in acidic medium, so that is why option A. Clear? Okay, now we will move to the long answer questions. So here also I don't have any 2-3 marker questions, because in the exam questions will be asked from the 5 marker section. So the first question that I have taken is from the model question paper 25-26, question number like model question paper 1 of 25-26, means this year model question paper, and question number 38 is this question. Okay, which type of amines answer for carbylamine reaction? Explain this reaction with an example. Okay, so first of all, which type of amines, that will give you 1 mark. Explaining of reaction will give you 1 mark. Example will give you 1 mark. So the first part carries 3 marks. Okay, you will never get a direct 5 marker question. It will always be in the form of 3 plus 2 or 2 plus 2 plus 1, but majority of the time 3 plus 2. So first we'll write, first which type of amines will show? Primary amines. Second, what is this reaction? So aliphatic or aromatic primary amines on heating with, what is the reagent used here? On heating with chloroform and ethanolic potassium hydroxide, okay, forms isocyanide or carbylamine, which are foul smelling substances. It is used as a test for primary amines. Okay, you can write one example. RNH2 plus CHCl3 KOH will give you RNC plus KCl plus water. This is the isocyanide formed here, because of which we have the foul smelling compound. Next, identify X and Y in the following conversion. So let us do this question here only. So first of all, you have C6H5NH2 and then NaNO2 and HCl. X will give you what? Benzene diazonium chloride, right? So we have N2 plus and Cl minus. Next, you treat it with what to give Y? So if you just treat it with Ki, okay, if you treat it with Ki, then what will happen? You will get KCl, you will get N2 gas, and I will be replaced here. So this is X equal to this one, and this is Y. Okay. Next, we'll move to question number 40. Explain carbylamine reaction with equation. Now, this question is again in model question number 238, question number 25-26 model question paper. Okay, so you can see this carbylamine reaction is repeated so many times, means how much important reaction is this one. So again, I have given the same explanation, so no need to discuss further. Complete the following reactions. So let us complete this part. 1 second. Yeah. So when you have this one, CHBF4, first you will get, see, HBF4 is there, then NaNO2 and Cu you are treating, right? So when you have first the intermediate here formed is, on adding of HBF4, you will get something like this. Okay, this bromine is added. Now this BF4 is added. Now when you again treat it with NaNO2 and Cu, so at that time what happens? At that time nitro, NO2 group is directly added. Okay, so here we have NO2 group added to this room, and then you have this one, that is HBF4 minus. Okay, HBF4, not HBF4 minus, HBF4 will be produced. Let's see the second question, that is complete the reaction. So you have this benzene diazonium chloride, and then you are treating with HBF4 and NaNO2Cu and heating rate, right? So when you treat with this HBF4, okay, you get a compound like this, where you have N2 plus and BF4 minus. Okay, this is the first compound formed. Now on treating with NaNO2 and Cu, we get something called as NO2. Okay, now what happens to this Na? This BF4 minus is N2 gas is produced, BF4 minus is there, Na plus is there, so you will get a compound like this NaBF4. Okay, that is the product formed here. Next, write the IUPAC name of the given compound. So you have 3 carbon here, so it is propanamine. Okay. Next, question number 40, we'll go to the next question, that is model question paper 3, question number 36, okay. And you can see, explain Hoffmann bromamide degradation reaction with a chemical equation, okay. So first let's see. So preparation of primary amines by treating an amide, okay. What is amide here? When you have RCONH2, that is called as amide, with bromine in an aqueous or ethanolic solution of sodium hydroxide, okay. In this degradation reaction, migration of an alkyl or aryl group takes place from the carbonyl carbon to the amide of the nitrogen atom. The amine so formed contains 1 carbon less than that of the present in the amide. Now I'll show you this reaction with an example. So you can see here that, one second. So if I write down this reaction, so if I have RCONH2, okay, so what you are reacting? See, preparation of primary amines by treating an amide with bromine in aqueous solution, okay. If you have bromine in any aqueous solution, or like bromine KOH if I take, of or ethanolic solution of sodium hydroxide, in this degradation reaction, migration of an alkyl or aryl group, migration of this alkyl or aryl group takes place from the carbonyl carbon of the amide to the nitrogen atom, means this group migrates here, okay. So what I will get here? RNH2, okay. So now this amine which is produced contains one carbon less than that of the amide group, because the CO group is not there, right? That is the question. Next, we'll do the IUPAC name. I'll discuss question number B, don't worry. So here you can see 1, 2, 3, 4. So I have NN diethyl and butane 2 amine, okay. Yeah, NN dimethyl, sorry, not pentane, it is butane, okay, butane 2 amine. Next, we'll see, discuss the coupling reaction of benzene disonium chloride with aniline. So when the reaction of disonium salt with aniline yields a para-aminobenzene. So you can see this is benzene disonium chloride, this is aniline. Here there is an electrophilic substitution and we get this particular compound, and this is para-aminobenzene, a yellow dye, okay. Next, we'll see question number from the model question paper of 24-25. Question number 35 is there. How do you distinguish primary, secondary and tertiary alcohols using a Hinsberg reagent with chemical equations involved, okay. So first of all, if you see, the Hinsberg test is used to differentiate between primary, secondary and tertiary amines. And what is this Hinsberg reagent? This is benzyl sulfonyl chloride, okay. And how do we get this? So primary amines, how will you differentiate? See, primary amines reacts with Hinsberg reagent to form a sulfonamide which contains an acidic hydrogen, okay. Now because of this acidic hydrogen, the product is soluble in an alkali. Now if you take secondary amines, in that case what happens? It reacts with Hinsberg reagent to give you a salt, okay, but it does not contain any acidic hydrogen. If there is no acidic hydrogen, it is insoluble in alkali. And for the tertiary one, if you see, the tertiary amines do not react with Hinsberg reagent, and that is why it is like, if it is not reacting at all, then you can differentiate. The second question is, give the preparation of para-hydroxyazobenzene. So benzene disonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with disonium salt to form para-hydroxybenzene. So like we have para-aminobenzene, it is same para-hydroxybenzene. This reaction is here and you will get the coupling product, which is your orange color dye, okay. Next, explain Hoffmann bromamide degradation by taking butanamide as an example. Give the IUPAC name of the product, okay. So you can see, just now we have discussed what is Hoffmann bromamide degradation, but here the question is asking to take butanamide with an example. So I will have CH3, CH2, CH2, C double bond O, NH2, okay. This is butanamide, and then when you are reacting it with Br2 and KOH, in that case what will happen? This CO group will be removed, and then we have CH3, CH2, CH2, NH2. Clear? Next question is pKb of aniline is more than methenamine, give reason. pKb of aniline is more than methenamine. Okay, so if you have aniline, okay, now see, in aniline what happens, the lone pair of electrons is involved in resonance. Okay, it is not available for donation. If it is not available for donation, then what will happen, the basicity will reduce. Whereas in methenamine, if you see, it is CH3NH2, right? There is lone pair of nitrogen. This R group will donate electrons and nitrogen can easily donate it electrons. So basicity here is more, here basicity is less. So what will happen then? In that case, we can say that since here the basicity is more, the pKb will be less. Okay, so option number here since the basicity is less, pKb will be more. Okay, so you can see aniline is less basic than methenamine as the lone pair of electrons on nitrogen of aniline is involved in resonance and is not available for basicity. So that is why it is less basic and more pKb. Okay, next we'll question, how do you prepare primary amines from Gabriel thalamide synthesis? Give equation. What are the advantages of Gabriel's reaction, and give a reason why aromatic primary amines cannot be prepared by using Gabriel thalamide reaction. So first let us see the Gabriel thalamide reaction. I'll show you that. Before that, let's talk about B and C. So in this method, in this Gabriel thalamide reaction, you can directly get like secondary and tertiary amines are not formed as byproducts. You will directly get your primary amine. Next one, why aromatic amines are not produced by this method? Because aryl halates do not undergo nucleophilic substitution reaction. Okay, because there is no nucleophilic substitution reaction. When I'll explain this answer A, you will find that there is a step where there is a nucleophilic substitution reaction. But we know that aryl halides do not undergo nucleophilic reactions, so that is why aryl amines cannot be prepared. Okay, so now let's understand Gabriel thalamide. So this is the thalamide taken, then you have taken a base here. Base will abstract the H plus, so you will have N minus and K plus. Then you have Rx. Okay, now see, here is the difference. If this one would have been an ARX, means if this would have been an haloarine, then you cannot break this Rx bond, right? But with this N minus K plus, this one will attack on this one. Okay, NR will form, and then you will have this N-alkyl thalamide is formed, and then on treating it with NaOH, what will happen? COO minus Na plus, OO minus Na plus RNH2 is formed here. Okay, clear this one? Okay, next we will see some questions from their basic nature. Amines act as nucleophiles or amines behaves as Lewis bases. Why? The reason is they have lone pairs of electrons, right? There is lone pair on nitrogen. Next, aliphatic amines are less strong bases than ammonia. One second. Okay. Aliphatic amines are not, stronger bases than ammonia, yes. So in aliphatic amine, there is R group. This R group can donate electrons to the nitrogen, increasing the electron density on the nitrogen and increasing the basicity of the aliphatic amines. Aromatic amines are weaker bases than ammonia, yes, because in aromatic amines, the lone pair of nitrogen is involved in resonance, okay. Next, arrange primary, secondary and tertiary amines in the basic in the increasing order of their basicity in the gaseous medium. In gaseous medium, it is 3, 2, 1. Okay. Arrange the following in the decreasing order of basicity in the aqueous medium, and R is the methyl group. So here you will have 2, 1, 3 and then ammonia. Okay. Now what is carbylamine reaction? Already we have discussed this reaction so many times, so I'll just not go again. So already you can see such an important reaction again and again in every model test paper, in every exam this question is asked, so please prepare this reaction thoroughly. Next, how does aliphatic primary amines reacts with nitrous acid? See, if you have aromatic amines, means if aniline is there and it reacts with nitrous acid to give you benzene disonium chloride, but aliphatic amines will react with nitrous acid to give you alcohols plus N2 gas. Okay, so how does it react? It reacts to give you alcohols. Name the gas liberated. The gas liberated is nitrogen gas. Name the product formed when methylamine reacts with nitrous acid. So it will be methanol, CH3OH. Next, what is diazotization, or how does the aromatic primary amine reacts with nitrous acid? So you can see what is diazotization, or how does the aromatic primary amine reacts with nitrous acid. Okay, so you can see aromatic amine reacts with nitrous acid at this lower temperature to give you benzene diazonium chloride. Next, what temperature should be maintained for diazotization? This is very important, 0 to 5 degree Celsius. Okay. Next, what is coupling reaction and give an example? So, benzene diazonium chloride can react with phenol or aniline to give azodize, and this is called as coupling reaction. You have coupling reaction with phenol to give you para-hydroxy-azobenzene. You can have coupling reaction with aniline to give you para-hydroxy-azobenzene. Okay. Okay, so students, these were the most important questions from the chapter aniline, from the amines. See, the weightage is less, so I have not picked up many questions, but I have picked up most important questions. So do revise these questions first and then only go for other questions. And if you have any doubt, you can put down your doubts in the comment section and I will address to them. Thank you so much for watching and all the best for your upcoming exams. And always remember, the teachers here are there with you. Please just keep on working hard. Very few days are left for the exam. Don't waste even a single day from now onwards. Okay. Thank you so much. Bye bye and take care.